All right, I think we're started. Started with a battery warning. See it flickering on the bottom there. You gotta start by plugging in my computer and then sitting at my desk, I guess, to do these notes. Shh! Come flying out of this chair if I have to. All right, sorry. Think I can't. All right. All right. So, what kind of shift is this when we look at a function and we do this to it? Right or left? It depends, if it's minus or plus. And then what kind of shift is this on the outside? Up or down? Now, I left this here. A is that now A is called amplitude, and there will be B's in here that change, and it really actually belongs in there. It's going to be crazy where this looks. That's why I kind of left it out though, because today we're just talking about up, down, and right, left shifts. Right, left stink. It's going to be the hardest thing. And as a matter of fact, I'm just the informant. Could everyone say this word? Phase shift. For some reason, I'm just the informant. When you have a trig right-left shift, it's called phase shift. I don't know. Just telling you. All right? So press pause for a second and chew on that for a little bit. It's a mess. Okay, it doesn't look pretty. Don't care. Shh. All right, this first one, I think it's the worst one that we have because I'm gonna go crazy and talk about drawing the second period just to show you how challenging that might be. And I do want you to spatially think about where things are in relation to the origin to be a little bit neat. Because watch what happens when we try to draw a second period. Now again, this is going to be tough. This is not for the lazies out there that kind of half listen to the notes. You really want to grasp this now. And then remember, I'm not going to be here tomorrow. Hooray! All right. I should have had an app ready for an applause. But the quiz is until Thursday. This is 2020 right now. I'll probably be using this video in 2026 to be honest, but this is last year teaching. Okay. Oh wait, maybe 27. I have 6 years after this. Okay, what's the amplitude, everybody? Huh? What's the amplitude? 1. What's the period if B, what's B equal to? Have you heard any of those questions so far that I've asked? What's B equal to? 1. So what does that mean the period's equal to? 2 pi. For anyone that's done any training of the last 2 days of graphing. All right, but now we have, okay, everybody, what's the phase shift? It's pi over 3, but which way? Right. It's actually right. Remember, inside we look opposite, outside same. That's kind of terminology that we talked about back in first semester. Or back up to here. That's why it's written like this: minus C plus D. If C is positive, then it's right. If C is negative, then you'd see X plus a number in there. Opposite. Then plus D if D is positive up, D negative down. That would be minus D on the outside is how that would look at. But anyway, it's pi over 3 right. And I hope you remember that right-left shifts. You think opposites. All right, this gets to be a problem. Here's how I think you should do it. This is how I've approached this every single year. Because I know how hard this is. You don't go right to the graph. You don't go right to the coordinate plane and start trying to mark the axis appropriately. You do your work off to the side. And you do the work of what are my critical values based off of the period before shifting. Well, the period's 2 pi. Hey, everybody, what's half of 2 pi? Pi. What's half of a half? What's half of pi? And then you do 1 pi over 2, 2 pi over 2. Anyone? Well, you should have seen that a million times already to know that these 4 are, the parent x-axis values. That's why people not writing the values on the x-axis, that's the whole point of the worksheet that I gave you. That's how people give me nothing. What is going on? I just can't even speak anymore. All right. Oh, okay. Well, this may confuse you. If I have to move these right, then what do I have to do to 0? Add or subtract pi over 3? Add. You're pushing them all right. So we're going to add pi over 3. Oh no. Of course, pi over 2 plus pi over 3 is pi over 5, right? And if you said that, get out of my room right now. I'm bringing Lexi Samuelus in here to teach you fractions. I keep saying her name over and over again. Oh, man. All right, pi over 3. Seniors. All right, 0 plus pi over 3 is easy. All right, what do you need for pi over 2 plus pi over 3? What would she tell you? Common denominator. All right, don't yell. All right, times 3 times 2. What do you end up with? 3 pi over 2 plus 2 pi over 2 is what? I'm sorry, 3 pi over 6 plus 2 pi over 6 is what? 5 pi over 6. You all right over here, student? You're rubbing your eyes here. You all right? Yeah, you okay? Okay, all right. Next, what's pi plus pi over 3? Someone randomly walking through the room. What does that become? Huh? 4 pi over 3. You know what you have to understand? This is going to be kind of tough, but you can keep this in terms of over 6s in your head. You're still going to be pi over 2 away each one of these. These are all pi over 2 away from each other. Oh gosh. So these are still pi over 2 away from each other. All right? I want you to think about that when we actually try to do a second period. I kind of jacked it up first hour like in my thinking, but times 3 and then times 2 again. We got another over 6. Is that 11 pi over 6? And then I guess what you could say is I could add another 3 pi over 6, which is, because that's pi over 2, and that's 14 pi over 6, which ends up being, 14 pi over 6 ends up being 7 pi over 3. Or if you just add these, 6 pi over 3 plus pi over 3 is 7 pi over 3. Okay, so what I started doing was adding like 3 pi over 6, which is the equivalent of pi over 2. These are still pi over 2 away from each other. 1/4 of whatever the period is. Okay, now we got to be careful. And I would like this way, but do the best you can. I'm not saying you necessarily be marked wrong here, but everything is in relation to where the origin is. The origin's right here. Pi over 3 is like right here. And this is all that I ask. What's bigger, pi over 3 or pi over 2? Pi over 2. This next space should look larger than the space the distance is back to the origin. Just try. So this is a distance of pi over 2. This is a distance of pi over 3. And I'm not going to get a measuring device to see if you're, and then make those equally, and I may not have enough. 1, 2, 3, 4. I'll just come out to here. And then you can mark these. 5 pi over 6. 4 pi over 3. 11 pi over 6. 7 pi over 3. And then that's the point. This is where the sine curve starts. It starts at pi over 3, comma. And just because it is 1, but I'm going to go like 2 units high just to stay away from my x-axis values. I'm going to go a little bit higher there. We could always mess with the scale. It doesn't matter. So if sine starts at pi over 3, it's pi over 3, comma what? 1, 0, or negative 1. Where do I put that point? 1, 0, or negative 1? 0, I heard enough people say, right through the bell. Then what's 5 pi over 6, comma? 1. I'm losing some people. If you don't know this, then I don't know what the worksheet was for, right? Okay, but that's the point. It moved right. This is still the starting point, but now it's at pi over 3, not 0. So that's why we still graph sine. What's 4 pi over 3, comma? 0, Mr. Samuelus. 11 pi over 6, negative 1, and then back to 0. All right. You've successfully done this. You've graphed through one period and you're done. But now for extra stuff, why this is the worst question of the day. It would become the worst question of the day if I asked you to graph 2 periods. Okay, but actually it's not a big deal. I think what we can do is go backwards, right? And then how do we go backwards? Well, we have to maybe put these in terms of over 6 to make it simple for ourselves, because that seemed to be the common denominator thread all the way through. And pi over 3 is 2 pi over 6. And what I want to do is subtract distances of pi over 2 backwards, all right? Because these are the next critical values, because the period goes in fourths of a value pi over 2. And that is 3 pi over 6. Hey, what's 2 pi over 6 minus 3 pi over 6? And then you would understand that negative pi over 6 is about half the distance away from the origin than pi over 3. And I'm going to put negative pi over 6. And then from that, subtract another 3 pi over 6, because that's a distance of pi over 2, which is where all of the critical values are at. You know, that's how far away they are, a fourth. What's negative pi over 6 minus 3 pi over 6? Negative 4 pi over 6, but what does that become? Negative 2 pi over 3. Now you want this distance to be the same here, so to give this a real good picture. So what I'm trying to do here, this is the worst that you might run into. And then we can keep going and subtract negative 3. What's minus another 3 pi over 6? I put an over 3. You're right. You're right. I don't know if someone said, did anyone say that? No, I'm a lie. It's over 3. I'm freaking out, man. It is an over 3 because I reduce. All right. So let's go back up to negative 4 pi over 6. Subtract another 3 pi over 6. Subtract another 3 pi over 6. What does that become? And notice it changes from an over 3 to an over 6, so that makes me feel good. And then you can take another 3 pi over 6, and what does that become? What's negative 10 pi over 6? You okay over there? Why are you giggling? Fractions funny? Okay, it's so simple. What does that become, sir? Negative 5 pi over 3. All right, and then boom. Notice the y-axis itself is not a critical value. Notice it gets skipped. So when we go from here to here, now I want a different color. Let's say like green. When I go from here to here, there is a y-axis value, but it's just not a special one. And that's sometimes what students have a hard time. If it's not a critical value, they still make it one of the critical values and put this as a point, and it is not. Okay, so that's some hard things we're going to run into today. And then back up to here, back up to the high point, and then back up to here. So there's another sine curve. And then the key is this. Again, all right, let's stop picking on you, but I don't know how we missed that, some of us. If you have no x-axis values on your worksheet, you're not getting a good grade. There's no excuse for missing that. None. All right, let's take a pause for a minute. Whew. What the problem is the phase shift doesn't work real well with the quarter value of the period. And that's why we ended up having this problem being a little bit complicated. I was just telling them I have this all highlighted in yellow. If you get this, you're ahead of the game. If you don't feel too bad. That is the hardest kind of question, when the phase shift doesn't work well with the quarter value of the period. All right, and then here's the book. Look at what they show you. It is hard to graph this way, though. To graph the original, then move everything. It's better to just get your original critical values, mathematically move them, then put it on the x-axis. All right, but there's actually a good drawing of what our answer actually is. We do have that. Look, and they also have negative pi over 6 identified as the next important value, oddly enough. That's strange. All right, next one. Oh, baby. Like it matters, but what's the amplitude? Meaning it's not really going to change our graph, because we just mess with the scale. What's the period again? What's the period? Just 2 pi. What's our phase shift on this one? Pi over 4, which way? Left. So as you're writing this down, we can fill in those things off to the right. And that'll give you some time. Oh, made that move. 3. The b value is 1. I kind of snuck it in here in my old notes. And then 2 pi over 1 is 2 pi. Period is always 2 pi over b. Then the phase shift in this case is pi over 4. Which way did you say? Left. What does that mean we have to do with the values? Do what with pi over 4? Add or subtract it? Subtract it. Okay, now we do have our same old 0 to 2 pi. Half of 2 pi is pi over... I'm sorry, half of 2 pi is pi. I want to write that larger. Oh, well. I don't know. Half of pi is pi over 2. 1 pi over 2. 2 pi over 2. 3 pi over 2. But in this case, you're going to subtract pi over 4. And then sometimes you can actually get the pattern here. And then you may not necessarily have to do all this common denominator work. You kind of get what's going on here. All right. Of course, 0 minus pi over 4 is negative pi over 4. And then getting a common denominator, times 2 times 2. Oh, no. All right, so that's what's 2 pi minus pi over 4? Pi over 4. And then what again, yet again, got skipped? The y, anyone? Axis. There is no 0 comma, just like the last one. But this one's not as hard as the last one. So when I take this and get this to be a common denominator, I think you can see a pattern here. 4 pi over 4 minus pi over 4 is 3 pi over 4. Without doing the math, what do you think the next one is? 5 pi over 4. What's the next one? 7 pi over 4. Sometimes it is that easy. The last one, not so much. We had to kind of work through it and then see what the pattern was. The pattern was it flip-flopped between an over 6 and an over 3 because of rounding your decimal, or rounding your decimal. What? Simplifying your fraction. Hi, caramba. I don't know what's going on with this brain of mine. That's a certain misfire right there. Anyway, you can see the pattern. And then for us to do 2 periods, it's going to be easy. All right, but we'll hold off on that for a second. I'm going to draw this. You guys fine over there? You okay? Loving the check in and then check out and then check in and then check out method of taking notes. Very effective. Okay, so here we go. Let's do this. Here's negative pi over 4, and this is what I want to aspire to do. Pi over 4, and then I want to keep this distance sacred. All right, so that my graph is not all like smushed and distorted and all cattywampus. All right, so that hopefully is the same distance, as that it looks close enough, and then that's where I put these values. So you really want to keep these distances the same so your graph is very nice and precise, nice looking. And then 7 pi over 4. Now I'll erase these little distance things. Then it's just for purposes for staying away from the, I could go all the way up. Yeah, what the heck. 3 and negative 3, and that is actually spaces of 3 on my grid that I have here, my piece of paper. Okay, it's cosine and it's regular, and it's got moved left, so this is where it starts. It starts right here. And how does cosine start? Is it the high point, 0, or low point? High point. Ow! Right away I destroy the 3. All right. Now, is this a critical value, yes or no, right here? No, that's the big deal, and people can't handle it. You know, if they don't do their math right and understand that I don't see 0 comma as a critical value, so that can't happen. I go here, what's pi over 4 comma what? Pi over 4 comma what? 0, sorry, I know. So this is my point. Oh, it crosses the y-axis. It's just not at one of our special values. All right, we can find out where it crosses. It's actually very easy, but then I'm going to have an aneurysm when people don't know this answer. Hey, when I plug in 0 for x, what's 0 plus pi over 4? What's the cosine of pi over 4 exactly? No, it's a cosine of a 45, which has been what a million times? Root 2 over 2. Root 2 over 2 is like 0.7 times 3. 3 times 0.7 might be approximately 0.21. Okay? Right? Doesn't that look like that's like right around 2-ish, like right there? My point is it's not a critical value. It's not exact. This is graphing 101. Input, say it. I should be able to find out what the y-intercept is. It's actually 3 root 2 over 2 exactly. Because cosine of pi over 4 is root 2 over 2, then times 3. Blah, blah, blah. Okay, and then 3 negative, and then back to 0, and then back up here. Students don't get, they want to get, how do I get the answer? And they don't get anything behind what we're doing. You know, so for me to go over that input-output thing. Hey, 2 periods ain't no thing, chicken wings. 1, 2, 3, 4. All of them are over, I just said the number. 4s. What's the next over 4 to the left? Negative 3. What's next? Negative 5. What's next? Negative 7. What's next? Sometimes 2 periods is the easiest thing in the world. It really depends upon, you know, how it's all shaken out. Back to 0, back to low point, back to 0. I know it says 1 period. 2 periods was nothing. I'm really liking my graphs today. Oh, baby. Except they got a little squiggly at the end there. All right, we'll take a break. Okay, then the book representation. Yeah, there's the one unshifted. It really isn't the parent graph because it is changed from 3 to negative 3 high top to bottom, but you get the idea. Before the shift dotted line, after shift blue. All right? All right. Okay, stop that with that pen. Is that a pencil? Stop that. I know, stop. Do the next one. Does anyone know about the 3 that you have in there? Hey, what's the phase shift? Is it pi left? Is it pi left? Is it? No. Does anyone know what it actually is? If it's not pi left? No, it's not right. It's still left. What? Pi over 3. We had this before. I couldn't think of a first hour where we had to get the right left shift correct. We had it in the regular because this is how all functions are affected. So we did have this where you had to say what were the right left shift, what was the up down shift. When you had a question like this, you had to factor. Oh, there's that word. Factor out the 3, and then that changes pi to pi over 3. Wait, is that right? Good FOILers are good what? Or good distributors are good factors. I'm not sure this is right. When I throw this back in, oh yeah, okay, 3x. Then when I throw this, does 3 times pi over 3 equal pi? Yes or no? That's the point of good distributors are good factors because they check. And then they can proceed on and actually do. So that was just a check. Is it pi over 3 when I pull a 3 out? And it should be easy at this point because if you're training in this class. All right, so we are going to do over 2 periods. This one's going to work out nicely. What's the amplitude? Is it negative 2? Is it yes or no? Never! You always say amplitude is positive. And if you put negative, I'm going to get you. All right, because it's a detail that you got to remember from our teachings. What's the period? 2 pi over 3. Okay, only a few people. And then is there a phase shift? Yes. And notice we have not had an up-down shift yet, okay? That would be outside of these parentheses plus or minus some number out here. I haven't had that yet. So we're waiting on that. We're getting the hard stuff done first. The up-down shift's really easy. It is really easy if you just listen to I think it's my last example, the next one, which is the last one. Okay. So still, now here's nice. You know why this is going to be nice? Look at the period. It's 2 pi over anyone? 3. And then look at the phase shift. It's pi over anyone? These are easy. Okay, that's actually half of a period shift. And these are going to work real nice how this works out. But I'm still going to do this. I'm going to do what your training from the worksheet should have been. The whole point of the he keeps complaining about this because I can't believe someone would think that getting the x-axis values is not important on their worksheet. That was the whole idea. Because then they play this game. What's half of 2 pi over 3? Okay, and I'm going to write this one more time. I shouldn't have to. What's half of 2 pi over 3? What happens to the 2's? They cancel. To not do that still, not be able to do that still, even in this class. If you walked in fractionally challenged, you should be less so in this class with my Jedi training. All right? What's half of pi over 3? Yeehaw, by the way, I forgot to say that. What's half of pi over 3? Pi over 6. 1 pi over 6. 2 pi over 6. Is that what I have over here? I can't move this. 3 pi over 6. What's 3 pi over 6? Pi over 2. I'll leave that. I like that's over there. Okay, and then we're going to go. What does it mean to go left pi over 3? Add or subtract? Subtract. It's getting frigid in here. You know what's great is St. Patrick's Day is coming up. Sign of spring always in my mind. And then I say sign of spring when we're going to hit 8 inches of snow between Tuesday to Wednesday. Nice. It's possible. That's what they said. That's the worst case scenario. Yeah, worst case scenario. Nope. All right, this should be easy. Look at this. Negative pi over 3. And then go to this one. This is 0 because, that's the second or the third one. What's pi over 6 minus pi over 3, do you think? Because these are all pi over 6 away from each other. Because these are all pi over 6 away from each other. We should always get familiar with the quarter period value. All right, and then we see a pattern here. What do you think this is going to be then? I mean, sometimes you could stop and say, okay, I get the pattern. What's next? We don't get it? Pi over what? Because I just said they're pi over 6 away. We have 0 in action now. Look at the y-axis gets to play. And then just look at what's this got to be? I mean, 2 pi over 3 minus pi over 3 is what anyway? Pi over 3, but you should... Sometimes you could recognize the patterns without having to keep subtracting fractions. And then this is going to be easy to do 2 periods, but let's take care of the first one. I don't care. I'm going to say it. It is going to be easy, and it should be. If we just have any knowledge of fractions. All right, I can go equal, and this is in. It's hard to show that this is in a special way that we don't forget it. And then I can put these values here. Negative pi over 3, negative pi over 6. I always get sad when people put these values and put like pi over 3 on the inside and pi over 6 outside of it. You got to understand bigger and smaller fractions. Pi over 3 is larger than pi over 6. The bigger the denominator, the smaller the thing. Oh, some crazy things I get on this. I'm done. All right, you still at this point have not dominated the fraction idea, even with your calculator in your hand. All right, let's get this graph done. This is it's cosine, but it's flipped. And the amplitude is 2. I'm just going to go real high up here. It doesn't matter about scaling. Just try to make these distances about the same. 2 and negative 2. Where do I start at negative pi over 3? High, 0, or low point? It's low because of the reflection. Let's get a different color than the x-axis, or the axes. Then negative pi over 6, comma what? 0. It's the cosine kid. So this is what's happening. Then 0, comma 2. And then 0 and then negative. And that should not be a problem. So it's an upside down cosine kid with those shifted values. But you know what's funny? What does this look like? If you started here and then continued this graph, what would that look like? What does that look like that I just did in yellow? A regular cosine kid. Isn't that wild? It's because I shifted it. I could create a new equation that's unshifted that actually has the exact same graph. That's what's kind of funny about this stuff. I think I have a question on the test where choose all that apply the equation that makes the picture that you see there. Woo! Then you got to know a little bit about shifting and how that could possibly happen. All right, hey, what's the next? And I don't care which way you go. You know what? I'm generally a positive guy, so I'm gonna go What? I'm gonna go positively. Someone really clearing their throat back there. Okay, being the students. No, don't do that. Hey, 1 pi over 6, 2 pi over 6. Anyone? 3 pi over. You write that. I'm going to mark it wrong so quick your head will be spinning. What's 3 pi over 6? Pi over 2. 4 pi over 6. You write that your head will be spinning and mark wrong. What's 4 pi over 6? Fumble. 2 pi over 3. 5 pi over 6. 6 pi over 6. You already ahead be spinning, mark you wrong. What's 6 pi over 6? Pi. And then we can continue the insanity. Alrighty. Press pause. Let you sink your teeth into that one. No way. I'll tell you why we're only going to do 1 period. Because 2 periods would be real easy and I could just reference it on the video. Notice what I don't have. Anyone notice what's different about this? These parentheses close right here. So what does this represent? Up 3. And there is no what, which is the worst thing in the world. There is no phase shift. That's good. Meaning phase shift is the hardest thing that you have to do in graphs. It truly and really is. Because of time, we're just going to go to that, and I'm going to go to this black area here and write in, what would be a good color in this? Maybe I'll pick a yellow. I'll do the graph in yellow. Okay, here's what you got to understand. I'm going to try to explain this in a real fast way here for you, and then show you why 2 periods is not going to be a big deal. I'm going to write this, but then I'm going to erase it. If this was the amplitude, which you can kind of see my yellow over there, wouldn't it go from 2 to negative 2, right? But then the whole graph gets shifted how far? Up 3. What does the new high point become then if it was 2 originally? 5. 1, 2, 3, 4, 5 is the new high point. This should not be rocket science. I should be able to just do this. And then negative 2 was the low point, but it gets moved up 3. So what is it now? 1. And then here's what I suggest you do. The x-axis, those were where the zeros were. Fumble. This is where the zeros were located, but they get moved. Anyone? 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 Up 3. So 1, 2, 3. What you should do is make a dotted line fake x-axis here. This is where the zeros are now. Okay? And then from here on out, it's easy. You just graph the graph based off of the dotted line. It's so simple. Hey, by the way, what is the period? 2 pi. I'm not doing math off to the side because there's no phase shift. What's the period? 2 pi over 3. What's half of 2 pi over 3? Pi over 3. What's half of pi over 3? Pi over 6. And this is why 2 periods wouldn't be a big deal, because you could just put the negatives over here. 1 pi over 6, 2 pi over 6, 3 pi over 6, which reduces to pi over 2. And it's a cosine kid that's flipped. So what do we start with? High point, middle, or low point? Low. 0 in quotation, air quotes, 0, but that's the new dotted line. Pi over 3 high. I think at 1, 2, 3, 4, so that is the mark for 5. 0, and then low. Up, down shifts ain't no thing, man. You know what? I don't like this picture as much as I like this one. Do you see that one? Ooh, and then I did some f of questions. See that off to the side? What's f of pi over 3? Well, f of pi over 3 ends up being this point up here, so it's 5. What's f of pi over 2? Well, that's right here, and that ended up right there, so that's 3. What's f of 2 pi over 3? Oh, that's the new low point, which is 1. All right, I love those questions. Alrighty then.